Here's one last technique for algebraic division. This is my favourite one. I think this is probably the most clearly mathematical, less of just kind of like an algorithm that you follow. And it takes a while to get your brain around it, but I think when you do, if you persevere and you really try to get your head around it, it sort of helps you explain a lot of things. So I'm just going to very quickly look at a very, very, very basic fraction. I remember doing this in primary school and being asked to write that as a mixed number. So that's amount of wholes and the remaining fractions. When we did this, I don't know about you, but I was always like, okay, right, how many lots of 2 fit into 13? And I'd run through my 2 times tables until I got to the biggest number of lots of 2s before it stopped fitting in. That, of course, would be 6. 6 lots of 2 is 12. So that would give me 6, which is 6 lots of 2, and that's the 12 that I wanted. And then I would have 1 left over, which is still being divided by 2. We're trying to use the same kind of idea here, but obviously with algebra and with a lot more of a complex expression to begin with. But that's the kind of idea I'm trying to go for here. So I'm going to take the first term. I'm going to say, right, how many lots of x, okay, technically x minus 1, but we're going to adjust for that in a minute, fit into x to the 4? Well, I think x cubed do, because x cubed times by x would give me x to the 4. So that's what I'm going to force my fraction to begin with. Now, obviously, I can't change my fraction. I can't do that. That would just be stupid. So I've gained an x to the 4 term, but I've also gained a minus x cubed term there by forcing, hence the name, forcing the denominator to appear in the numerator. So I've got my x to the 4, good, but I've also gained here a minus x cubed. Now, I actually want 3x cubed. So to get from minus x cubed to 3x cubed, I'm going to have to add 4x cubed. My fraction still isn't the same. I still need to add a 7x, and I still need to take... Oh, this is exciting. Let's try that bit again. Undo, there we go. I also need to take 2. So if you were to expand this expression out here that I've just written and simplify all the terms, you would get back to the original numerator. If you can't see that, pause the video and actually try that to convince yourself. So now I've got my fraction. All I've done is replace the numerator to look a little different. I've just looked at that very first term. I'm going to use the v at this point, so don't forget the v allows me to isolate a term or terms in a fraction and write them as 2 separate fractions. So there's one section of my v and there's the other section. So that gives me x cubed x minus 1 over x minus 1 and 4x. Let's try that again. There we go. 4x cubed plus 7x minus 2 over x minus 1. Notice now, helpfully, these 2 terms cancel, and that leaves me with, let's try that bit. Oh well. Oh my gosh, what's happening to my pen? There we go. Small technical freak out there. I'm left now with x cubed on that first fraction. I've left with a whole amount, and now I've got a different fraction to consider, but I'm just going to apply the same technique to it again. So the same idea that I just did a minute ago, I'm going to go again on this one. So, leaving my x cubed alone, leave that there. In order to force the denominator into the numerator, I need to create this 4x cubed term. So I've got an x squared, so I'm going to need 4x squared to create that 4x cubed term there. In addition to that, I've also given myself minus 4x squared. Well, there are no x squared terms in my denominator, so I'm going to have to add 4x squared to get rid of them. I still haven't got my 7x, so I'll put that in. and I don't have my minus 2. Okay, so now our fraction should match what we had previously, and I can use the v again on this cheeky bit of v to separate out these fractions. So that's the way I'm going to split things up, like that. So that's I've still got my x cubed, don't lose that somehow along the way. I've now got 4x squared x minus 1 over x minus 1 and 4x squared plus 7x minus 2 over x minus 1. Now again, these terms cancel and I'm left with another whole sort of, well, part of my quotient, but a 4x squared there, and now I've just got this bit that's left over this bit that's left over the divisor that I had there. Okay, so we're going to go again. See if you can work just one step ahead of the video now. So leaving my terms here, I'm going to try and force the denominator to appear in the numerator to make this first expansion of this bracket make up this 4x squared. I'm going to put 4x here, but that gains me minus 4x. I need to get up to 7x, so that's 11x to add on, minus 2. If I expand and collect all the terms on this numerator, it will end up being the same as the numerator above, unless I've made a mistake. Using the v then across here and across here and across here, we end up with still my x cubed, careful those terms don't translate differently, 4x squared plus, right, I'm going to jump this step, it's 4x, because it would be 4x, x minus 1 over x minus 1, and then 11x minus 2 over x plus 1, x minus 1 rather. Okay, one more time through this, I'm just going to have to chuck it down the side here. We get x cubed plus 4x squared plus 4x plus 11 lots of x minus 1, which gives me 11x, good, and then minus 11 I don't want, I need minus 2, so I've got to add 9, and those are the two bits over the divisor now. Using the v, we can separate those two fractions out, giving you 11 and then 9 over x minus 1. And we can't go any more because this constant term 9 is of a smaller degree of order than the linear term on the bottom, and so that is us.